So welcome students to my channel once again. In this video I have brought this sum for you all. So look at the sum. If one root of the quadratic equation ax square plus bx plus c is equal to 0 is equal to the nth power of the other root, then a into c to the power n whole to the power 1 by n plus 1 plus a to the power n into c whole to the power 1 by n plus 1 plus b is equal to dash 0, 1, 2, half. 4 options have been given. You have to find which one is correct. Okay. So let's start the solution. Okay, one root of the equation, this equation is equal to the nth power of the other root. So let us assume that let alpha and alpha to the power n. It has been said that one root of the equation is equal to the nth power of the other root. So let alpha and alpha to the power n be the roots of, what is the equation? Ax square plus bx plus c is equal to 0. Okay, let alpha and alpha to the power n be the roots of this equation. So then what are the sum of the roots? Alpha plus alpha to the power n. Sum of the roots are minus b by a. Clear? Name it equation 1. And product of the roots, that means alpha into alpha to the power n. Alpha into alpha to the power n is c by a. Name it as equation 2. Right? So from equation 2, okay, from equation 2 we can write that alpha, both the bases are same, so alpha to the power n plus 1 or 1 plus n. Okay, alpha to the power n plus 1 is c by a. We can write from equation 2 alpha to the power n plus 1 is equal to c by a. Okay, so name it equation 3. Okay, alpha to the power n plus 1 is equal to c by a. Okay, so now alpha can be written as c by a to the power 1 by n plus 1. Okay, alpha can be written as c by a to the power 1 by n plus 1. Okay, and alpha to the power n, alpha can be written in this way, c by a to the power 1 by n plus 1, and alpha to the power n can be written as c by a to the power n by n plus 1. I hope no doubt. Okay, so now what will you do? Alpha is equal to c by a to the power 1 by n plus 1 and alpha to the power n c by a to the power n by n plus 1. So now we'll put these values. Putting the values of alpha, okay, putting the values of alpha and alpha to the power n in equation 1. Okay, we'll put these values in equation 1. Okay, what was equation 1? Equation 1 was this one, alpha plus alpha to the power n is equal to minus b by a. So we'll replace alpha by c by a to the power 1 by n plus c by a to the power 1 by n plus 1. So we will write c by a to the power 1 by n plus 1 plus alpha to the power n. So alpha to the power n is what? C by a to the power n by n plus 1. So c by a to the power n by n plus 1. Okay, is equal to minus b by a. Okay, equal to minus b by a. Clear? Okay. So now what will I do? Acha. This can be written as c to the power 1 by n plus 1. Okay, by a to the power 1 by n plus 1. Okay, plus c to the power n by n plus 1 by a to the power n by n plus 1. Okay, minus b by a from right hand side, I am bringing it to left hand side, so it will be plus b by a is equal to 0. Clear? Okay, so now what will I do? I will multiply both the side. I will multiply both the side by a. Okay, so what will I do? I will multiply both the side a into, okay, c to the power 1 by n plus 1 by a to the power 1 by n plus 1 plus c to the power n by n plus 1 a to the power n by n plus 1 plus b by a is equal to a into 0. Okay, clear? So it will be now a into c to the power 1 by n plus 1 a into a, sorry, in the denominator it will be a to the power 1 by n plus 1. Okay, only I will multiply it with the numerator. Okay, plus it will be a into c to the power n by n plus 1 a n by n plus 1. Okay, and here b by a into a is equal to 0. A into 0 is 0. Okay, so here a will cancel each other. Okay, simple. So now what will I do? I will, here the base is 1. When in case of division it will be 1 minus 1 by n plus 1 into c to the power 1 by n plus 1. Okay, right, plus a to the power 1 minus n by n plus 1. Okay, into c to the power n by n plus 1 plus b is equal to 0. No problem. Okay, so here now a LCM will be n plus 1, So n plus 1 minus 1 into c to the power 1 by n plus 1 plus a, LCM will be n plus 1, n plus 1 minus n, okay, into c to the power n by n plus 1 plus b is equal to 0. Okay, clear? So it will be plus 1 minus 1 will cancel each other, so it will be a to the power n by n plus 1, okay, a to the power n by n plus 1 into c to the power 1 by n plus 1 plus a minus n plus n will cancel each other, 1 by n plus 1 into c to the power n by n plus 1 plus b is equal to 0. Okay, okay, so now what will I do? So it will be a to the power n into c to the power 1 by n plus 1, I can write. Okay, can I write a to the power n into c to the power 1 by n plus 1, and here plus a into c to the power n to the power 1 by n plus 1, I can write a into c to the power n whole to the power 1 by n plus 1. Okay, then it will be a to the power 1 by n plus 1 as it is, then c to the power n by n plus 1, then plus b is equal to 0. So this can be written as a into c to the power n 1 by n plus 1 plus, I am writing this the second term I am writing it at first, then this I am writing this term, a to the power n into c to the power 1 by n plus 1 plus b is equal to 0. See the question, it has been given to us. Then a into c to the power n to the power 1 by n plus 1, a into c to the power n to the power 1 by n plus 1 plus a to the power n into c whole to the power 1 by n plus 1, a to the power n into c then whole to the power 1 by n plus 1 plus b is equal to dash, it was the question, plus b is equal to 0. So option number A is the correct option, 0. Clear? Thank you.